Hello, everyone. Good afternoon. My name is Sunshine Menezes, and I'm pleased to welcome you to our next Metcalf Institute webinar. This is part of a series we do called Climate Change in the News, which we developed to help journalists all over the country and even all over the world better cover climate change stories by introducing you to new sources and new story ideas. And as part of that, we're really pleased to welcome Dr. Katharine Hayhoe today. Dr. Hayhoe is an associate professor in the Department of Political Science and director of the Climate Science Center at Texas Tech University, which is part of the Department of Interior's South Central Climate Science Center. In her research, she works to establish a scientific basis for assessing the regional to local scale impacts of climate change on human systems and on the natural environment. In short, she's working to develop better ways of translating climate projections into information that's relevant to agriculture, ecosystems, energy, infrastructure, public health, and water resources. She's also the founder and CEO of Atmos Research, which is a boundary-spanning organization that bridges the gap between scientists and stakeholders to provide state-of-the-art information on how climate change will affect our lives for a broad range of nonprofit, industry, and government clients. She is very actively involved in efforts to promote meaningful dialogue about climate change impacts among a diverse cross-section of public audiences. And we're really pleased to have her here today as part of our webinar series. So with that, what she's going to talk about today is the fact that nearly 200 nations recently signed the Paris Agreement in an effort to cap global warming to 1.5 degrees, maybe, hopefully. Today, Dr. Hayhoe is going to talk about what it might take for us to achieve the Paris Agreement's goals. And I'd also like to note that you should please feel free to send us your questions as her presentation is going. You can send those questions via Twitter using the hashtag MetcalfCC, or you can send a question to webinars@metcalfinstitute.org. Or you can submit your questions via our Google Plus page. So with that, I am going to, unmute Dr. Hayhoe and present her to everyone and hand this over. Dr. Hayhoe.
Thank you. Can you hear me?
I can.
Okay, can you see me?
I can.
Okay, we're good then. I'm going to start with some slides. So let's make sure that we can share the screen here. Desktop. All right. Can you see the full screen now?
Yes, yes, I can.
All right, thank you. I've been asked to talk about the Paris target. And specifically, I've been asked to talk about what science can bring to the table. So I know that the title of this series is Climate in the News. I'm going to begin with some very old news. And by old, I mean really old. Because often we don't realize how far this science goes back. Our news cycle is always focusing on new science. In fact, there was a very funny John Oliver episode the other day about how we're always seizing on new science, saying coffee is good, coffee is bad, chocolate is good, chocolate is bad. Climate science is very old science. And every time a new study comes out, it isn't disagreeing with the previous study, it's reinforcing science that has been around for almost 200 years. What am I talking about? Well, it was back in the 1820s when Fourier, who's also a very accomplished mathematician, figured out that, according to basic physics, our planet should be a frozen ball of ice. Our planet should be about 60 degrees Fahrenheit or over 30 degrees Celsius colder than it is right now, just due to basic physics, how much energy we get from the sun and how much of that energy we give off. So he said there's got to be something else going on, and maybe it has to do with our atmosphere. But it wasn't until a couple of decades later that an American scientist, who unfortunately I've not been able to find a photo of yet, her name is Eunice Foote, she figured out that heat-trapping gases like carbon dioxide, methane, and water vapor in the Earth's atmosphere were what was causing this very livable, warm climate that we have on our planet that enables life. And then just a decade later, an Irish physicist called Tyndall was the one who figured out that human activities like coal mining, he was in the middle of the Industrial Revolution in the United Kingdom in the 1800s, he figured out that activities like coal mining release more of these heat-trapping gases into the atmosphere. That's how old the science is. So it's no surprise that by 1965, which is more than 50 years ago, there was enough scientific evidence for the President's Council of Advisors on Science and Technology, that's all those men standing there in a semicircle, sadly they were all men at that time, they felt like they had enough science 50 years ago to formally warn the President that continuing to build up carbon dioxide in the atmosphere from burning fossil fuels would, and this is a direct quote, almost certainly cause significant changes that could be deleterious or harmful from the point of view of human beings. This was 50 years ago. It wasn't until 1998 that the Intergovernmental Panel on Climate Change was founded. And this is literally a picture of their first meeting. So the IPCC was founded by the United Nations Environmental Program and the World Meteorological Organization. And they got busy very quickly. It was just a year later, at the Second World Climate Conference in Geneva in 1990, that the IPCC called for this global treaty. So here's an interesting thing, is that what we're seeing in Paris today was actually initiated by scientists, because the IPCC is made up of scientists. In that sense, I really think of climate scientists almost like physicians. If we have, kind of a low-grade but troublesome fever, we go to the doctor runs the tests, and the doctor gives us a diagnosis and says treatment is needed. That's what climate scientists have been doing for over 100 years. We've been running the tests on the low-grade fever our planet has. We've been diagnosing the cause for the first time in the history of the planet. It is humans. And we've been saying we need a treatment. And that goes back all the way to 1990. That's more than 25 years ago. So, not ones to let grass grow under their feet, the United Nations began negotiations 1 year later. And this is a picture of the first negotiations towards that global treaty. By June 1992, they had a treaty in place. It was the United Nations Framework Convention on Climate Change. And at that point, that was the same point that we just reached in December this year, where you have a treaty that has been agreed upon. At that point, the signing began in order to ratify it. The Paris Treaty is not yet ratified, and the UNFCCC was not ratified in June 1992. It was not ratified until 1994 because all of the countries had to take it home and agree in their country that they would support it. So what did this Framework Convention on Climate Change say? It said something very basic and very important. It said, we agree, and again, this was ratified by I think over 160 countries around the world. It said, we agree to achieve stabilization of greenhouse or heat-trapping gas concentrations, so that's how much carbon dioxide and methane there is in the atmosphere, at a level that would prevent dangerous human interference with the climate system. And you might say, well, but that's all we need, right? It is. But that was more than 20 years ago. So since then, I don't know if you know, but the Paris meeting was the 21st Conference of Parties. That's where COP comes from, Conference of Parties. It was the 21st Conference of Parties to this United Nations Framework Convention on Climate Change. You might say, but this is very clear. Why did we need 21 subsequent meetings to come up with another agreement? For one simple reason. What is dangerous is not a scientific judgment. How many cigarettes? What is the precise number of cigarettes that you can smoke without getting lung cancer? Depends on your genetics. Some people smoke a little bit and they get it. Some people smoke a lot and they never do. How much carbon dioxide and methane and other heat-trapping gases would cause dangerous human interference with the climate system? If you go up to people living in the Arctic, they would say, well, we've already gotten to that point. If you talk to Texas, they would say, what are you talking about? If you go to the Philippines, they would say, yeah, we're already pretty much there, maybe a little bit more. Dangerous is not a scientific term. Dangerous has to do with our values, it has to do with our vulnerabilities, and it has to do with our priorities. So that's why we have been having 21 subsequent meetings to try to figure out what's dangerous, because science can't answer that question. So what has been going on since then? This is a partial timeline from 1992 just to 2009, leading up to Copenhagen, where you can see that there have been various protocols. The United States rejected the Kyoto Protocol, Russia ratified the Kyoto Protocol, then there was a Bali Action Plan and the Copenhagen Accord. This has been going on and on and on. What is the role of science in all of this? Because as we just saw, the fundamental science was there before the IPCC was even founded. So what has the role of science continued to be in this international negotiation process? Well, thankfully, the United Nations Framework Convention on Climate Change has a helpful infographic that actually explains it. So this is their infographic. Science is doing four main things. It is observing the changes that are occurring. It is figuring out what is causing these changes. It is understanding what's happening and how it's impacting us, and then it's looking to the future. This is what science has continued to do over the last 25 years. What does that look like? Well, it looks like things like tracking global temperature, where we know that from year to year it can go up and down, but 2014 was the warmest year on record. 2015 is now the warmest year on record, and as of this past month, there's about a 99% chance that 2016 will be the warmest year on record thanks to the big El Nino we just came out of. Science also tracks other indicators of a warming planet, whether it's melting permafrost in the Arctic, whether it's stronger hurricanes in the Gulf of Mexico, whether it's killer heat waves in Australia, so strong they had to add a new color to their temperature map. That purple in the middle is 54 degrees Celsius, 129 Fahrenheit. They had to add it a couple years ago because they'd never had conditions that hot before. Or whether it's the crazy flooding that we have, not just up in the Northeast, but even down here in Texas. This is a picture literally 2 blocks away from my office where I'm talking to you today. It was a year and a half ago in September. This is a 6-lane freeway underwater. And those are our undergraduates floating away. That was a joke. When we look around the planet, though, just looking at the natural environment, we see more than 26,500 indicators of a warming planet, and that is the information the science has carefully compiled over the last 25 years. We have also carefully charted the impacts per degree. Why is this important? It's important because the international targets are expressed in degrees. So this is just one figure from a report that I would encourage you to look into, published by the National Academy of Sciences in 2011. It was a report called Emissions Concentrations and Impacts over Decades to Millennia. And in this National Academy report, which I participated in along with Susan Solomon and Dave Lobel, who made this figure, we looked for water, health, energy, and food-related thresholds that we would cross as the world warms by 1 or 2 or 3 or 4 degrees. So this gives you an example, though, of why dangerous is a relative term. Because say that you are a US soybean producer. That'd be you in the blue line. You might say, oh, but when we get to 2 degrees, my yields will be just about the same as they are today, so 2 degrees doesn't seem dangerous to me. But say you're an India wheat producer or an African maize or corn producer. You'd say, oh my goodness, 2 looks terrible. We'd be at, minus 25%. We'd be losing a quarter of our yield on average. We have to go for less than that. Well, obviously, there's a major disagreement that has nothing to do with the science. It has everything to do with what we perceive to be dangerous. So since that report, I've tried to frame a lot of my own research in this same way. Rather than looking at what's going to happen under a given scenario in the 2020s or 2040s or 2080s, I try to look at what's going to happen as the world warms by 1 or 2 or 3 or 4 degrees. So this is a paper, for example, I just published last year, looking at the risk of drought in Texas, New Mexico, and Oklahoma. Now, you talk to the average farmer or rancher or producer in Texas, and you say, you know, how does your crops, how does your decision making tie into the Paris Agreement? They'd look at you like you were crazy. They say, what are you talking about? But by framing our research, our scientific research, in terms of here is what Texas spring, that's the top level, or Texas summer, that's the bottom level, drought risk will look like if the world warms by 1 or 2 or 3 or 4 degrees. Why don't you, farmer, or you, producer, or you, ag co-op, you look at this and you tell me what looks dangerous. Does 2 degrees still look tolerable? Is it 3 degrees before we get to dangerous? Or does 1 degree already look severe in summer? This is a way for science to connect the dots between individual stakeholders, communities, states, and even entire countries, and the types of targets we're talking about in Paris. So there is more that science can contribute, because this is a way of empowering individuals and community groups and regional organizations to actually decide what is dangerous for them and to pass that information back up. And this isn't just being done at the local scale, it's being done at the global scale. Because the bottom line is, when we look at where our carbon emissions have come from over the last 100 years, the darker the country, the more carbon emissions have come from that country. The United States is responsible for about 30% of cumulative carbon emissions. And then we compare this exact map. So fix this map in your head. We're going to compare this exact map to who will be most impacted by a changing climate. Ready? Here we go. It's pretty much exactly the opposite. So these 2 maps, if I could pick 2 figures out of everything I'm showing you, these 2 maps explain why we've spent 25 years arguing over what is dangerous. Because who has to do the most reducing? The United States, Canada, China, Russia, and Western Europe, and Australia. Who is already bearing the impact? Everyone else. That is why we've been arguing. Because where the emissions are coming from is not the same place as where is feeling the worst of the impacts. Why is that? It's simply because of the vulnerability of our social systems. I was looking at the Syria drought the other day, and I was amazed to realize that the severity of the Syria drought, at least for a couple of years, not the whole time, was almost the same as we had in Texas the past 5 years. But in Texas, we don't see civil war in the streets. We don't see the world debating what to do about all the unrest and violence. Why? It's because we had a stable system. We have technology to use the aquifer. We didn't have a corrupt system that prevented farmers from digging wells. We had a stable political system. We have crop insurance. The vulnerabilities come from the issues that these countries already face, and climate change is adding an extra straw to the back of a camel who is already staggering under the load. And what's the last thing science can give us? The last thing science can give us is this. What is this? This is connecting our carbon emissions to our temperature change. And this figure comes from that National Academy report, Emissions, Concentrations, and Impacts Over Decades to Millennia. You can Google it, and they have a really nice short PDF called Warming by Degrees that you can look at. So this figure comes from Warming by Degrees, and it shows, with the range of uncertainty in terms of how much carbon uptake will happen, it shows where our carbon levels are if we want to achieve 1 or 2 degrees. Now, this dashed line is emitted to date 5 years ago. So the dashed line has to go up to about 0.7 now. So you can see we don't have 1.5 on this figure, but we are getting darn close to the total amount of carbon we can produce to meet 1.5. There is a hard limit on it. Now, there are certainly technologies to suck carbon out of the air. There's some amazing technologies people are working on to do that. And they would help us by adding a buffer to this bar. But there is a hard limit on how much carbon we can put out if we're going to stay below 1.5 degrees. And we are already Again, we don't have the 1.5 degree bar here, but you can imagine what it looks like, halfway between 1 and 2. We are already hitting the lower end of the range of uncertainty. So if climate turns out to be much more sensitive than we thought, if the carbon cycle turns out to be much more sensitive than we thought, then chances are we have already possibly ensured 1.5 degrees. But that's why it's important to develop the technology that could suck the stuff back out. So these are the ways that we normally look at future projections when we're doing our climate modeling. We look at a higher scenario where we depend on fossil fuels and a lower scenario where we depend on clean energy. But here's where the science comes in. Connecting this to global temperature, like we just saw before, has some uncertainty in it. Because for a given scenario, these are a higher and a lower scenario again, but now we're not looking at carbon emissions. The last figure was carbon emissions. So this is the actual carbon emissions from human activities. Now we're looking at the temperature change. And there's this range of uncertainty because we have never conducted an experiment with our planet of the magnitude that we're conducting right now. So when we kick our planet down the road, so to speak, to use a soccer metaphor, if we kick our planet down the road, we don't know how far it's going to go because we've never kicked it this hard before. That's the range of colored uncertainty that you see there. So all of this information is summarized very concisely in reports like the AAAS's What We Know report. If you haven't seen this, I encourage you to look it up. It was released just 1.5 years ago, and it provides a fantastic summary of what we know. And we were able to boil it down to 3 things. We know that climate change is happening here and now. We know that we are at serious risk of pushing the climate system towards abrupt, unpredictable, and potentially irreversible changes with highly damaging impacts. So you can see how the language has changed in the last 50 years, right? Remember that report to Lyndon B. Johnson 50 years ago? This is a very similar report 50 years on. The language has changed, it has intensified, it has become stronger, but the basic science is the same. And the last point is a simple one. The sooner we act, the lower the risk and the cost, and there is much we can do. So you've probably seen this cartoon, but I had to show it because this is really from the perspective of a physical climate scientist, which is what I am. This is really what the IPCC has been doing on observations, on attribution, and on understanding climate change. We start off by saying, this thing could be a problem, and then, yeah, it's definitely a problem. We should be sorting this thing out pretty soon. By 2007, look, I'm sorry I'm sounding like a broken record. By 2013, probably some American scientists, we really have checked and we are not making this thing up. And then you can imagine the press release for the next one, is this microphone on? Is anybody listening? Thankfully, people are listening. The science cannot go any further than what I have showed you. We can document the changes, we can understand why they're happening, we can quantify the impacts, but we can't say what the world must do. That is why, for 2 weeks in December, 195 nations came to Paris. They came from China, they came from Southeast Asia, they came from developing countries, and they were all there because every country has now realized that it is cheaper to do something about climate change than not to. And so there, countries agreed to reduce carbon emissions and to support poor nations already threatened by climate change. We here in the United States tend to focus on the reducing carbon. We have to realize the vast majority of nations and more text in the Paris Agreement is focused on how to support the poor nations who are already bearing the brunt of the impacts today and in the future. So a few words to end with. What is the current status? The Paris Agreement is not ratified. It must be ratified by countries individually that in total account for at least 55% of global emissions. So that is why the contribution of China and India is so important, and they were definitely at the table with a plan on how to do this. That is why the contribution of the United States is so important, because these are the big emitters. What have countries promised to do? Because each country came to the table with a promise of what they could do. What they've promised to do, their pledges, are the red shaded area. And this plot is of global heat trapping gas emissions. So not just carbon dioxide, but methane and everything all lumped together. So the blue is current policy projections. This is from the climateactiontracker.org. The red is what people have pledged to do. But the light green is what they must do to be consistent with 2 degrees. And the dark green is what we must do to be consistent with 1 degree. What does this show us? It shows us that yes, things are changing, but no, we do not yet have enough to reach 1.5 degrees. And it also shows us that we have a very narrow window of time in which to act. The choices we are making today and in the next few years will put into place policies and infrastructure that could be with us for not just years, but decades. So that is why even little steps like the Clean Power Plant Act are important now, because they are starting to shift that trajectory from the red down to the light green and hopefully down to the darker green. We don't have a lot of time to do that. The window is still open. Even though we may hit 1.5 degrees this year, 1 year doesn't make that much of a difference, and it certainly doesn't make a climate trend. Climate change is the average over 20 to 30 years. We have not yet hit 1.5 degrees on a climate timescale, and we don't have to, but we don't have a lot of time to move. So this is why we're now in the policy part of it. They've chosen a goal, they're taking action, and there's not a lot we scientists can do at this point other than continue to beat the drum on the urgency and the importance of acting. There is a road, and this is another infographic, this one from Greenpeace. There is a road beyond Paris. It includes all countries giving us mitigation commitments. There will be another commitment cycle at COP31. Kind of scares me to see that number. And another commitment cycle at COP41, along with continuous support for both adaptation and mitigation in poor countries. There is a road ahead. But as John Holdren, the President's Science Advisor, says, at this point in time, we have 3 choices: reducing emissions, preparing for a different future, and suffering. And we are going to do some of each. The question today is what the mix is going to be. We don't have the option of just choosing one. We have to do them all. What does that look like? It looks like acknowledging simply that climate change is a real problem affecting real people today, whether we're flooded out in Texas or whether we're flooded out in Bangladesh. It looks like preparing for a changing climate, whether it's floating villages in the Netherlands, so when sea level rises, you just let out the anchor chain, or whether it's replacing old pivot-style irrigation in Texas with in-ground drip irrigation so we're not wasting water in a warmer climate. And most of all, it looks like reducing our carbon emissions and investing in the new clean energy economy, whether it's putting a solar panel on a thatched roof hut in Africa that has never had power before, or whether it looks like this picture from right where I live in Texas, where shiny white wind turbines are replacing old oil rigs. This is the path forward. And this is the path that has been set in place at COP21, but there is still much more to do. And I really believe that in moving forward, we need to be moving forward with hope that is informed by responsible, realistic science. But not with the type of, it's all over, we're going to hell in a handbasket, it's too late mentality that we so often hear when we turn on the news. Because that type of perspective just paralyzes us. It won't let us move forward. Thank you.
Thank you, Katharine. That was great. And while you remove the talk from your screen, I have received a few questions for you. So I'll share these and here, put this back to you now. Okay, so here's a question. Can you talk about the public television show in Texas that you're hosting called Global Weirding, and how you hope to counter your observation that, quote, the vast majority, end quote, of the public where you live in Texas don't think climate change is real?
Mm-hmm. Absolutely. Well, the show that we're doing is from here, but it is a national show. So our audience is not only West Texas, it's everybody who has access to PBS around the country. But what we're going to be doing is, and we specifically designed this to be coming from West Texas, is we're going to be talking about climate science, politics, and religion. Because here in the United States, those three have gotten so involved that it's almost impossible to separate if we're not aware of how one influences the other. So we're going to step on a few toes. We're going to get into a few touchy topics. We've already started filming. We've done 4 of our episodes so far. We have 6 more coming up, and they're going to be released in the fall. They're all short, between 5 to 7 minutes, and they're all talking about a myth that we've heard, and then what the truth is behind that. And they mostly aren't science myths. Those of you familiar with skeptical science will know that skeptical science does a fantastic job with science myths. How do we know it's not a natural cycle? How do we know it's not the sun? What about this? What about that? We're going to address a few more subtle myths, a few more insidious myths like, well, I have to be a certain type of person to care about climate change. And of course, if I'm this type of person, I care. But if I'm this other type of person, then I don't care, because that's not where my politics are or my religion is. So that's just a kind of a little snippet of what we're going to be talking about.
That's great. Thank you. There is a related question here that I'll just ask it, and you can decide if you want to go to how much you want to go into this or not. The potential intersections of scientific evidence and religious beliefs in debates about climate change. Do you want to talk any more about that particular aspect of this communication challenge?
Sure. So first of all, I just want to point out that this is definitely a bit of a longer topic. And so I have an essay I've written on climate politics and religion at Prairie Fire, which is a Midwest independent news source. So if you Google my name and Prairie Fire, it'll pop right up. And I also have a talk I've given that's on Vimeo in Portland at the Oregon World Council of Affairs, where I talk about how scientific uncertainty and religion are both used as smoke screens to hide the real reason that we object to climate science. So if you're a reader, look for my Prairie Fire article. And if you're a watcher, look for the Portland or Oregon Council of World Affairs presentation given in June last year on Vimeo. To summarize that in 1 minute, though, what I would say is, when you look at the social science, it's definitely true that if people are more to the conservative side of the religious spectrum, and this holds true for Catholics and Protestants, if we're more to the conservative side of the religious spectrum, we tend to be more doubtful of the reality of climate change. And so a lot of people have conflated correlation with causation. Because when you talk to people, they will say things, and when you listen to politicians, they will say things like, God would never let this happen, you know, the world is going to end anyway. So they have these religious sounding arguments. But both through personal conversations I've had with thousands of people in these categories, as well as through peer-reviewed social science, which I love, it's very clear that correlation does not equal causation. What happens is there's a very strong correlation between conservative Christians and conservative people ideologically and politically in this country. I mean, it's gotten to the point where in some evangelical churches, it's almost like being Republican is part of the statement of faith. So what's happening is, yes, there is a causation between being very conservative politically and saying climate change isn't real. And religion just happens to get conflated in there because of the connection between conservative politics and conservative religion. Why is there a causality there? It's because most of the solutions to climate change involve government action. Whether it's a free market approach like putting a price on carbon, or whether it's more of a mandated approach by picking technologies to invest in or by putting policies in place, they all involve government. And, you know, about 30 to 40% of the country would probably rather cut off their arm than have more government involvement in their lives. I mean, that might be an extreme statement, but where I come from, I think they might do that. So the situation is that we need a dialogue on solutions. And that's part of why I love citizens' climate lobbies, because they really are trying to get a bipartisan dialogue going. We need dialogues on solutions that involve people from the whole spectrum. Because, you know, a thermometer isn't Democrat or Republican. The science isn't telling us a different number depending on how we vote. We have to just move beyond the science and start talking about solutions, because, again, social science has showed that if we have a problem, any problem, not just climate change, but we talk to people about this problem without talking about a solution that they could possibly agree with, contribute to, invest in personally, then people's acceptance of the reality of the problem is abysmal. Whereas if we present a problem, any type of problem, even losing weight, but we present it with a viable solution, people are willing to say, oh, so I can be part of the solution? I already am part of the solution? Wow, I'm actually doing a few things right? That's amazing. I will get on board. And that's why the solutions discussion is so important.
Great. Thank you, Katharine. That's great. This makes me wonder something myself, actually, which is whether you have any specific examples of success stories from your experience in working with these individual stakeholders using your temperature-based, impacts-based approach toward your research questions. You mentioned that you're working with farmers and you're working with all these individual stakeholders, and I think it's nice, in the interest of sharing hope with people, it's nice to hear some examples of how this has worked really effectively. Are there any that you can share with us?
Yeah. I'm working with all kinds of cities all the way through Texas, not just Austin. I mean, you would kind of take for granted that Austin would be on board with climate preparedness and resilience, and they are. But for example, I just finished a project with a very small little town called San Angelo, where most of the people we were working with in the city came to this thinking, I don't think this thing's real, but I'll just show up and give it a chance. So what we had to do is we had to start very slowly. You have to start with looking at historical trends and bring everybody kind of on board, and then start asking questions. How are you affected by drought? How are you affected by wildfire? How are you affected by extreme heat? Get people's stories, and then take their stories and turn those into historical trends. Specifically using local data, saying, hey, we're going to look at your airport weather station. Did you know that the risk of 100-degree days has doubled over the past X number of decades? And they say, oh yeah, that makes sense. I've been here and I've felt it. And then say, well, did you know that this trend's going to continue? Because we're seeing this all around the world, not just here. So what would you do if it quadrupled? Oh my goodness, I don't know. Well, let's see when when it's likely to quadruple. Oh, it looks like it'll be about 30 years. Well, what are we going to do to make sure that we could be prepared for that? And then they start coming out with the solutions and the ideas. Here's what we could do. We could do this. And sometimes I can bring in ideas from other cities. Well, other cities have considered doing this or that. And so that two-way engagement is so important, because so often people feel like they're just being talked down to. I mean, everybody knows, everybody has heard that, driving a big, inefficient old truck produces heat-trapping gases that cause climate change. Even people who say that it isn't happening know that they're being told that. So often we feel like we're just being talked down to when people just come in and say, come in and say, hey, did you not know about this? How could you not know about this? You need to be doing this. Look at all the stuff you're doing wrong. It's much better to start by asking, by learning, by figuring out what they're doing right, and then by working together to try to figure out solutions that are already going on. So that's talking about climate resilience, preparedness. But even we can do it with solutions, because when I talk to Texas audiences, I talk about how, well, the number one thing we can do is transition to clean energy. And then I give them a bunch of factoids. Did you know that we already generate 10% of our energy from wind? We generate on a windy day up to 50% of our energy from wind in Texas already. Did you know that Fort Hood, which is the biggest Army base in the United States, Fort Hood just went to wind and solar because it would save $165 million? Did you know that there's this little town called Georgetown just north of Austin that went 100% green because it was the cheapest electricity contract they could get? So when you start telling people this, it's like, people are like, oh, so we're doing stuff right in Texas. This feels good. We're on the right path. And then it's a completely different dynamic, because it feels like, oh, we're already moving in the right direction. We're already leaders in this area. Let's go a little bit faster. Let's do a little bit more.
That's great. Thank you. I think that's exactly the kind of example that I wanted to offer. And do you have time for one last question? Mm-hmm. Wonderful. Okay. This just came in, and here's the question. Can you say something more about how different nations feel climate impacts? I thought I heard you say, says this person, that the nations feeling impacts first or most strongly were primarily doing this because of social or political structures. Did I hear that right?
You did.
And okay, she did. And then the second part was, I thought the degree of climate impact was related primarily to geography / region / local ecosystem differences. and that lack of social structures exacerbated the problems. So can you clarify that?
Yeah. So in the disaster kind of relief risk mitigation field, whatever that field is called, there's a very simple formula that I think is really important. And I did a Facebook post on this just a couple of days ago. So if you go to my Facebook page, which is just my name, Katharine Hayhoe, and you go down about 3 posts, there's a post that starts with this equation. And the equation says hazard plus vulnerability equals risk. So the hazard is the climate hazard. It's the more frequent heavy rain events, it's the stronger hurricanes, it's the killer heat waves, it's the sea level rise. That's the hazard. But the hazard plus the vulnerability is what equals the risk. So in other words, you could have the same flood in Texas and in India. And the financial economic impacts, the number of people who are displaced, the recovery period, the number of people who are never able to regain their former standard of life will be radically different between the two. Now, it's totally true that, for example, some places see a lot more heavy rain events than others. Some places are going to be hit by hurricanes and others won't. You know, if you don't live on the coastline, you're not going to be getting the hurricanes. If you're not kind of in the tropical area, you won't be seeing them, or the mid-latitudes. So there's definitely regional impacts, and they vary from the Arctic all the way to the tropics. But the risk doesn't just depend on the climate hazard. It also depends very strongly on our vulnerability too. Now, I'm not saying that we have the ability to become resilient to everything climate change can throw at us. We can't. And the warmer it gets, the less we can. But the reason why 1.5 degrees, one of the reasons why 1.5 degrees has been picked as a target is because for many areas of the world, it's felt that we can reduce the vulnerability to such an extent that the increase in the hazard might not change the risk too much. And that's what the Green Climate Fund is all about, is funding poor countries to decrease their vulnerability. And so if you go to my Facebook page, I have a really cool story from Ethiopia, looking at how they have changed their food distribution network so that nowadays when they get the same type of drought that caused the brutal famine that they had back in the 1980s, they've had that same kind of drought again, and they haven't had the famine because they had the same hazard, but they've changed their vulnerability.
Wonderful. Well, thank you so much, Dr. Hayhoe. We were really thrilled to have you today. It was a pleasure to have you here as part of this program. And with that, I will sign off. Thanks to all of you who've joined us, and we will have this video archived on our YouTube channel, so you can see it there if you want to view again. And we also have a lot of other YouTube videos, many of them on our channel, so please take a few minutes to look that over and see what other resources we can offer. Thanks again, Katharine.
Thank you.
All right, and everybody have a great afternoon. Thanks.